Yeah, by the way, this is not, I did not prepare these slides. They were prepared by the author of HDFql. He couldn't come to this event, and he asked me if I would sort of do a poor imitation of his presentation, and that was an easy job, so I took that. Okay, it's about HDFql, and we'll begin at the beginning, and it's basically the idea that many of the call it language bindings or interfaces, they are imperative in nature. So when we talk about imperative programming, do this, do that in your favorite language, and that's it. But we all, anybody of us who has been exposed to a query language will appreciate sort of a more declarative approach where you just state your intention and then some magic will figure out for you what needs to happen. And that is basically what HDFql does for you. It requires, it of course takes the gold standard for these query languages, which is still SQL, and makes some extensions to it. And then of course you can have a debate and say, well, will that ever make it into the SQL standard? I think the answer is no, but then is that really that important, or is that a criterion for not using it? And that's what HDFql is. And as with SQL, okay, here he talks briefly about who uses it. There is actually quite a user base out there, and I use it myself occasionally too. Like in SQL, there are sort of different parts of the language dealing with different things. And so in the case of HDFql, it acts as a data definition language where you can define groups or as a net effect, create groups in a HDF5 file or data sets and so forth, attributes. It's a data manipulation language where you can insert data into data sets, update attributes and so forth. And obviously it's also a query language, that's what the Q is for, where you can read data from data sets. In the case of HDF, that would be hyperslab selections, point selections and so forth, or get the values of attributes. And but it's also a data introspection language where, like in a database, you would like to interrogate the catalog to find out what are the tables, what are the types of the columns, and things like that. And it serves to that purpose as well. And then let's look at a few examples here as a data definition language to give you the flavor. You can just say, create file, my file. And maybe before I continue, like many, take MySQL or any of the big database vendors, their database products typically come with a command line shell where you can interactively type queries, evaluate them, and see the results. This comes with HDFql as well, but then also the author here provides language bindings for Java, C++, Python, Java, C++, C#, and there might be a few others that I don't remember right now, where basically the API is pretty much the same. Anybody who has worked with sort of SQL-based persistence APIs in Java or something like that, there is typically like a context object that you can create, and you compose a query through string interpolation or something like that, and then you basically give that query, that expression to this context object, and you basically say execute this or evaluate this, and that then will give you some kind of result object. And that's pretty much the same API in all these different languages that I just mentioned. And so you can either do this interactively, like in a Python shell or something like that, but you can also do it then programmatically in many different languages. Okay, so we can create files. He also supports MPI. So if you have multiple MPI tasks and you would like to use an HDF5 file through the MPI-IO parallel interface, then you would add this in parallel qualifier to it, and the assumption would be, yeah, you would have multiple instances in different processes of HDFql running. You can create groups. Then it's very concise, as you can see here, to create a database with zlib compression enabled, where you just specify the dimensions, in this case, two-dimensional 20 by 40 floating point. That's very short and concise, as it should be. To see the data manipulation language in action, insert into is sort of the standard way to do this in query languages. He also supports CSV imports, or in this case, if you would like to import values from an Excel spreadsheet, that's supported as well. So in this case, it would go to the first, I forgot, in an Excel, I think the whole thing is called a workbook, and then in the workbook you have multiple worksheets. There's also syntax if you have multiple worksheets in there. I think if you just specify an Excel file name, it's going to pick the first one, but you have more fine granular control over that if you like. And then, he also supports the, this would be a write chunk when he says insert directly into raw, which would be a handle to a data set, these values. And hyperslab selection, so the syntax is obviously NumPy inspired. This is how you would do that. And then in all of this, you might ask, well, how, if this is sort of a query language that is sort of independent, it's like a guest language that is sort of executed in the context of a host language, how do I create a data structure in memory and then kind of inject that or hand that over? And he uses this memory slot syntax. So in this last example here, where you see memory 0, he has this kind of, call it a stack model, where when you create a data structure, you can register it with SQL, with HDFql, and it in return just gives you an integer or positive, non-negative integer identifier that you can then use in a query. So when you, for example, retrieve a value and you say, put the output into this memory object in my host language, then that's how you do it, or you provide values to be written into the HDF5 file. You can say if you registered in a certain buffer or array as memory 15, then if you make reference to 15 in a query, HDFql can figure that out for you. Here, other examples of the data query language, just from a data set. You can also, on the fly, actually export rather than retrieving the values into your host environment, sort of export it into an Excel spreadsheet or a raw binary file, or a, by raw binary file, I mean just unformatted I/O, or into a CSV file, for example. And then likewise, the select directly would be the read chunk, the H5D read chunk function that would be invoked here. And then, yeah, the other example, we have an in-memory buffer that is somehow registered as 0. Then that's how you would retrieve values into that buffer. And finally, sort of this introspection aspect of the language, where you can just show, so as with many of these context objects, there is, like in a shell, for example, there is a working directory and so forth. So in this case, it's a working group. So if you just type show in HDFql, it would show you information about the working group, so to speak. Or you can specify a path, or you can sort of use wildcards or regular expressions if you want to further restrict, like this last example, where you want to show attributes below a group, where the name contains a 1 or 3. And so the current version of HDFql is HDFql 2.4.0, and here he has actually the list. I think I was pretty close: C, C++, Java, Python, C#, Fortran, and R. On the major platforms, we are supporting direct chunk writes and reads, both irregular, so that is point selections, and hyperslab selections. I actually don't know what he means by irregular maybe by irregular hyperslab selections he means straight hyperslab selections plus the set theoretic operations that you can do with unions and differences and intersections and whatnot. It supports both serial and parallel HDF5, and then the ability to import data from text from unformatted binary Excel as one of the popular choices, into data sets, into attributes, and so forth. And I think he has a preview. He expects to release HDFql 2.5 in the last quarter of this year. It will be based off HDF5 1823, which has not been the current HDF18 is 1822, but there will be another one, and Dana will say more about that. There is also, we've seen that with, I think Andy mentioned it earlier, storing functions or the execution state of functions in HDF5 file. We have seen that also with HDF5 UDF, I believe, which we will hear about tomorrow. And he is doing that same thing, that you can pretty much load shared libraries where you can then look for functions that do aggregation, custom aggregation. But of course, it's good to support certain household aggregation functions like min, max, and average and whatnot in sort of as part of the standard distribution. But then, yeah, so the naming convention that he envisions at the moment for that would be HDFql dummy.so. You can then call dummy. If you call dummy in an HDFql context, then that will look for that shared library, look for that entry point, and basically execute it on your data. Support for streaming data or paging, that's coming for HDFql 2.5. Also, I talked about these memory slots, and then, yeah, in the current version of HDFql 2.4, you have to, in a way, inquire in advance and find out, well, how big of a buffer do I need, and sort of do all that allocation. However, that is going to be much, much easier in 2.5, because in a way you can always ask, well, doesn't the engine know what the type of that data set is and so forth, and can't it infer for me how much buffer space it needs and whatnot? And the answer is yes. It just takes time to build all that mechanics, and so that's coming in 2.5. And then this is a Java-specific thing, supporting variable. He supports variable length data already in many other host languages, but sort of Java and C# were sort of laggards in that regard, but he'll catch up on that. And then it looks like, yeah, Go is next on the list as one of the host languages that he would like to support. And and then we are looking at 3.0. So you might say there, and he can speak much better to why he uses 1.8, the 1.8 family of releases. So what's definitely coming is he's going to transition to 1.10. He would like to support virtual data sets, Swimmer, dynamically loaded filters, but then also HSDS endpoints, or just sort of blobs, HDF5 file blobs that are stored in S3, for example, or the S3 compatible object stores. And then, yeah, support MATLAB, I think, is high on his list. And here are some links, reference data, and I believe That's the last slide. Any questions? Please.
Okay. Your HDFql language looks rather similar to SQL and DZL, etc. So the question is, can you take a native DZL or SQL file and process by HDFql? Or maybe you have some converters from SQL, for example, to HDFql.
Do you want to query traditional relational databases, let's say an HDF5 side by side, and make that more transparent? Or I'm not understanding.
Yes, imagine that we have some application working with SQL database.
Okay.
And producing some SQL requests. For example, can we apply this SQL request to HDFDL? Or we need some specific translation of them?
Yeah. Excellent question. I think at the moment I'm way out of my league here because I'm not the developer of HDFql. But a scenario where I think what you are describing would work is, let's say, you could have in Excel a worksheet where you have a table or a worksheet that's backed like by an ODBC connection. So the worksheet would actually be populated when you open the Excel file and you switch to that worksheet. It would do a refresh and then query a database, for example. Now, if you use then the insert into capability, I would imagine that when you reference that worksheet in that Excel file to insert into the database, as a side effect, you would actually be querying a relational database, for example. But I have not tried that myself, but that would be a way maybe to improvise at the moment or to achieve what I think you are suggesting. Thanks. Yeah. Yeah. Well, Dana is here. I mean, we talked about, we had that discussion in the past several times, and I think we have not consciously decided against it or said never. But it's, of course, it's a big ask, and I mean, there might be other intermediate steps that maybe for users, my question would be then, do really people need the same kind of transactions with all the asset properties? That's what we are talking about in the end. Do they really need that? Do they actually make sense? Because you can sort of take AC, ID, and so forth, and ask yourself, what would be the meaning or the counterpart of that for HDF5? So that would be one discussion. But then the other one is there might be more HDF native or HDF type capabilities. We will talk, for example, about the Onion VFD tomorrow or on Thursday, where like file versioning. This is something that existed in VMS, for example, in sort of one of the granddaddies of operating systems, where you would have that functional property where you would never overwrite. It's about destroying history in a way. Rather than overwriting in place, you would create a new version. Not the same as a transaction, certainly not, but in many use cases may actually be sufficient rather than going sort of full in with the whole transactional. Yeah. Yeah, yeah, yeah. Not so much destroy it, but render it inaccessible, or yeah, yeah. Yeah. Mm-hmm, mm-hmm, mm-hmm. Yeah. Mm-hmm. Yeah. Oh, let's see. Do we have any online questions? How would I tell? Oh, yeah, yeah. Somebody said it would be nice, right, to summarize the questions. Yeah. Mm-hmm.
So you want to answer offline?
Right. No, the question we just talked about was about transactions. Would we consider having transactions? And it seemed like HDFql would be a natural place, but that would require a lot more from the HDF5 side.